This regression coefficient for study hours indicates that controlling for mother's education and school quality, we have to note both of them because they're both in the model now. Controlling for mother's education and school quality, a 1 unit increase in study hours leads to a 0.023 unit increase in grades, which is not statistically significant. T with 396 degrees of freedom, right? Yes, 396 degrees of freedom equals 1.369, P's 0.172. Yeah, not significant. We can do a 95% confidence interval for study hours. Now, we have to again look up what's the critical T for 396 degrees of freedom. Well, we actually already did that. It's the same as the last, when we did the simultaneous, right? We did with 396 degrees of freedom. Because if you think about it, wait a second, that is the same model as when we did the simultaneous, when we entered them all together. The last step is the same as the simultaneous regression. Other than we have father's education, so it's not exactly the same. Oh, so scratch that. Oh. I need to edit that out of the film. See, I thought I kind of went a little on my own there. That's a problem winging it. Okay, so let me take a step back. And see, my notes right there had it. I got notes right there on my screen telling me don't do what I just did. So we can actually go back and calculate a 95% confidence interval for study hours. We use the same formula. 95% confidence interval is the regression coefficient plus or minus the critical t-score times the standard error. So we have to go through and determine what the critical t-score is for a t with 396 degrees of freedom. It's a little different than what we did earlier, but within rounding, it's still the same critical t-score. 1.966 is our critical t-score for 396 degrees of freedom. That just tells us 95% of the distribution is within plus or minus 1.966, a t-score of plus or minus 1.966. We plug those in. Our regression coefficient was 0.023. Our critical t was 1.966. Our standard error is 0.017. We do 1.966 times 0.017, we get 0.0334. 0.023 minus 0.0334 gives us negative 0.0104. 0.023 plus 0.0334 gives us positive 0.0564. So now we notice it straddles 0. 0 is somewhere in that range. So we're not confident that the actual value is 0 because we've just said it. The value could very well be 0 within our degrees of confidence. Kind of a way of thinking about that. Here's our 95% confidence interval, right? Here is literally what the slope would look like if it was 0, if there's no effect. Right? That's what our slope looks like if there's no effect. We observed a regression coefficient, a slope of 0.023. It's not 0, but it's not too big either. That's what our slope looks like. But if Anika went and did the same study with the same population and got another sample, her regression coefficient is going to be a little different. And if Kavanaugh did, his is going to be a little different. We're all going to get slightly different regression coefficients. And we're all trying to estimate what reality is. So we know that what the 95% confidence interval is helping us do is get a sense of that range around what we would see. Just like the standard error is doing, kind of what would we expect to be seen. if we actually use those confidence intervals, we're thinking, if we kind of plotted the area covered by those confidence intervals. So now I've shaded in the range from a slope of negative 0.104 to a slope of positive 0.564. I've shaded that in. Now you kind of clearly see, oh yeah, 0 is right in that range. That's why our p-value is less than 0.05. We're rejecting the null. It's all kind of looking at the same thing. So that's the idea with the confidence intervals. Why you want to look is 0 in that range, then we can't be confident. If 0 is in that range, if your confidence interval covers 0, you're kind of stuck like an angry Willy Wonka.
You get nothing. You lose.
You lose. No effect.
Can you repeat that? We are not confident in terms of what?
You're not confident that you can think of our confidence interval is saying we're not sufficiently confident that the true population value isn't 0. We're not confident that the actual effect, because we're trying to estimate what the real value is. We're not confident within 95% that the actual effect is not equal to 0.
For study hours.
I'm sorry? For study hours. We can do the same. Let's look at, kind of contrast that with mom's education. So mom's education, the effect says that controlling for school quality and study hours, a 1 unit increase in mom's education leads to a 0.110 unit increase in grades. Right? 1.110 unit increase in grades. That effect is statistically significant. T with 396 degrees of freedom equals 5.790. P is less than 0.001. We can do a confidence interval for that. It's, kind of exactly the same. The critical T with 396 degrees of freedom is 1.966. We just need to plug in our regression coefficients and the standard error for mom's education. So here, if we take mom's education, the regression coefficient is 0.110. So B, we put in 0.110. The T critical is 1.96. Our standard error for mom's education is 0.019. So we do times 0.019, 1.966 times 1.019. Notice this has changed a bit, is 0.0374. 0.110 minus 0.0374 is positive 0.0726. And 0.110 plus 0.0374 is positive 0.1474. So kind of visualizing that, there's the confidence intervals. Again, that says no effect. You get nothing, you lose. There's our observed effect for mother's education, a 0.110. And that's the confidence interval. That's the kind of that range that we're predicting, in terms of our confidence interval. And you notice now it does not overlap 0. So we're confident that 0 is not in that range. We're confident that no effect is not in our range, or that we're sufficiently confident there is an effect. But again, what's nice with the confidence intervals, it gives you, instead of just that point estimate of exactly 0.11, it's 0.7 to 0.14. It's kind of nice to know it's not even close to 0, so that makes me feel a little better too. But it gives you some better sense of what to expect. The finally, school quality, we've already gone through this. You can read that. I won't repeat it one more time. visually, this is what our model looks like in Model 3. That actually is a complete arrow. I need to kind of bump that beta behind that line so that that's, there's nothing weird going on with that little break. What we're looking at, here's our 3 regression coefficients. Our coefficient for school quality, that's the unique effect of school quality, not related to anything else. Here, not related to the other 2 variables. Here's the unique effect of mother's education, not related to the other 2 variables. And here's the unique effect of study hours, not related to either of the 2 variables. So it's those unique effects each has. You can think of it as it's also their direct effect, right? When we did our little pass, it was like the indirect effect for school quality was this way, and the direct effect was this, unrelated to everything else. It's the direct effect in the final model. Each of these are the direct effect of each variable in the final model. We can look at the semi-partial correlations. They're doing exactly the same thing. That's the unique effect of each variable. If we square them, it's the unique variance of each variable. It's the unique variance in the outcome that's related to each predictor. So we take each of those and square it. The unique effect of mom's education in Model 3 is 0.072. The unique effect of school quality is 0.013, right? 0.114 squared. The unique effect of study hours is 0.064 squared, or 0.004, right? Everyone see that? So we take each of these and square them. That gives us their unique effect. Going back to our Venn diagrams, this is what we're looking at. Now we've got a lot of grayed out areas where there's overlap. That's not, this is unique only mom's education, this is unique only to school quality, and this is only related to study hours. You get something like this is related to all 3 of them. This is related to school quality and mom's education, and this is, you get all the overlapping effects that they share with each other is grayed out. That's not what we're talking about with the unique effects. Okay, so you see with the sequential approach, we kind of were going through, and each variable that we ended up accounting for the total variance, each variable along the way adding it took whatever was its effect at that step. It planted its flag, basically took credit for all the associated variance, and then the next variable was left over, kind of accounting for its effect after that. Gosh, if I could go back, I'd do one more. I think I want to. Sorry, Willie. This really kind of sums up the sequential approach. I want to put this as like the final slide in the future. Right? It tells you the effect each variable has sequentially. It's looking at the total effect of mom's education, then the total effect for school quality, controlling for mom's education, then the total effect of study hours, controlling for mom's education and school quality. And the effect of each is examined, controlling for the others before it. We can start to do, we haven't done it yet, but what we will learn in a few weeks then is how to deal with questions of like all those indirect effects. Because we're still only, notice we've talked about the direct effect of the variables. Here's the direct effect of each of those variables. We've talked about their total effect when they entered the model before. The total effect of mom's education was when it was in the model all on its own. And then it went down a little bit when we added school quality. Oh, what is it at this point? Now the beta is, it went from 357 was the total effect of mom's education. Now it's down to 0.299. is its direct effect, its unique effect. Its direct effect is 0.399, so the indirect effect is somewhere, right? So we've talked about the total effect, we've talked about the direct effect, but we've not talked about calculating the indirect effects. So when we get to path analysis in a couple weeks, that's where we're going to go through and we'll calculate for every variable. What's its total effect? What's its direct effect? What's its indirect effect? Based on a model. But so kind of sequential multiple regression is getting us there. Not quite all the way to that sort of approach, but it's starting to lay that groundwork. And the key is that you've got a theory that's telling you how to order the variables. And you order the variables because you want variables that are those underlying, those initial variables to get the credit. They get the credit for their effect versus, you know what? See, I'm kind of rambling here. Where did it go?
You get
Sorry, Willie. Versus here, where we're only looking at the unique effects. Another way, if you do a simultaneous regression, these are the effects you're looking at. Because remember, simultaneous only looks at the direct effects, only looks at their unique effects. So a simultaneous regression, this is the focus. Versus the theoretically, kind of, or I guess analytically, you can kind of see the difference. With versus the sequential, you're saying, no, the effect of mother's education isn't this, it's all of this. The effect of school quality isn't just this, it's all of that. Okay, let's keep going. One more. We have the Lee Van Cleef.